Hello everyone, welcome to this lecture. In this lecture, we will see what is kernel. So kernel is a software first of all, and it is a fundamental component of an operating system. So what it means? So it is a software program that act as a core of an operating system, directly interacting with the hardware and managing various system resources. So whenever we are using keyboard, mouse, or any hardware devices, so how it is communicated to the operating system through kernel. So Linux is a kernel. Red Hat Enterprise Linux is an operating system. Ubuntu is an operating system, whereas Linux is the kernel for that. So the primary purpose of kernel is to enable the communication between software application and the hardware application, right? Or hardware components. So for example, if I say that my MS Word application is to run, it needs memory, it needs CPU, which are the hardware devices. So kernel is the one who is basically enabling this interaction between my MS Word application requirement and the hardware, ensuring that computer resources are utilized efficiently and securely. So now let me just show you one diagram. So it will make more clear understanding about the kernel. So here you can see we are having the hardware. On top of that, we are having kernel. And on top of that, my application or user processes are running. Okay. Now, if we talk about where this kernel is residing inside the operating system. Okay. So operating system is on top of the kernel. So if we talk about especially Linux or type of kernel, so Linux kernel is having a hardware at the on the physical server level or system level. On top of that, we are having kernel, which is interacting with this hardware, and we are having a shell. Shell is the user mode by which user can interact with the kernel. For example, if you run any command, so that command you run it on the shell, and shell sends the signals or system calls to kernel, and kernel send it to the hardware. And there are some other applications which are running in the background or foreground. So those are the applications. So this is how kernel is basically is useful to interact applications or shell commands into the connect to the hardware. So if we take two modes, one is called kernel mode, one is called the user mode. So whenever user is writing some command, which is called the system call, and at that time, mode bit, so there is a bit which tells that you are in a user mode. So it is one, and there is a trap basically which send it to the kernel, and kernel take that system call and execute it. At that time, the mode bit is 0. It means it is handling a trap or system call. Once the execution is done, then mode bit is changed to 1 and it returned to the system call with the output. So this is how internally user mode and kernel mode works. User mode, where you write the command, kernel mode, where those commands are really or actually get executed. Right. Now, uh, so the application running in the user mode invokes the system call. The processor switches the user to kernel mode. This happens because system call involve accessing system resources that are only available in the kernel mode. So kernel executes the request, which might involve the communication with hardware. After request is completed, the process switches back to the user mode, right? So this theoretical part you can just go through, and what kernels do, it basically manages the processes, it manages the memory. This is process means CPU, memory means RAM, devices, which are basically printer, network devices, etc. This is managed by the kernel. File system management, because we need to store the data. on the hard disk. So read, write, all these access, these are managed by the kernel. System call, the kernel exposes a system call, which are interfaces that allow user level program application to request services from the kernel. So whenever we run a command, that is called the system call. For example, system call includes creating new process, reading from a file, allocating the memory. And security, kernel enforces the security policies and access the control to protect the system and user data from unauthorized access and malicious software. Now, inter-process communication. So kernel also facilitates the communication between different processes through various IPC inter-process communication mechanism, allowing them to share and synchronize the action. So that's it for the kernel point of view. In next lecture, we will see what are the different types of kernels. Till then, bye-bye.